Hi everyone, and welcome to this Wine Australia webinar on the Climate Atlas. Today we'll be looking into the Climate Atlas with our Greater Victoria lens on. So welcome, especially if you're dialing in from Victoria. Hope you're safe and well. I'm Sharon Harvey. I'm a Research and Development Program Manager here at Wine Australia. And in the Control Central here with me, I have Belinda Bramley, who's our Extension Officer, and we'll be making sure things go smoothly from a technical perspective. Next to me on the screen, you will see Dr. Rebecca Harris and Dr. Tom Remini from the University of Tasmania, and they're the researchers that did the project that delivered the Climate Atlas for the wine sector. Just a bit of housekeeping before we start. So the format will be about a half an hour to 45-minute presentation by Beck and Tom, after which there'll be an interactive Q&A session. So during the presentation, if you think of any questions, please click on the chat tab that you can see on your screen. You can type your question in there. We'll curate them in the background, and then they'll form the basis of the Q&A session at the end. Please note that this webinar is being recorded and it will be available on the Wine Australia website at its conclusion. Just to quickly brief you that the aim of today is to provide you with some information that will allow you to interpret the atlas. We'll illustrate that with examples from wine regions in Greater Victoria, and that will allow you to go away and drive the discussion in your region and individually about how you might apply some adaptive measures to what you learn from the atlas. So without further ado, I'll pass over to Beck and Tom for the presentation, and I'll see you out the other side.
Thanks, Sharon. Thanks to everyone for joining. It's nice to be here. Tom is going to share his screen, and I will start with the presentation, and then he'll finish off by going into the details of in the atlas. So while Tom gets his screen up, I'll just sort of give a little bit of background to the Australia's Wine Future, which was a collaborative research project that I led that was funded by Wine Australia, and it brought together researchers from a range of disciplines, including climate modellers and scientists, viticulturalists, and people with expertise in adaptation. And it was because Wine Australia was recognising the challenges that climate change will increasingly pose for not just the wine sector, but sectors across Australia and the world. Temperature increases of up to 3.5 or 4 degrees relative to 1961 to 1990 are actually projected to occur by the end of the century under a high emissions scenario, which is the scenario that we're currently tracking slightly above. So Australia's Wine Future aimed to give the Australian wine sector climate information that was tailored for the wine sector and that was at a fine enough resolution to inform targeted adaptation responses. And so the focus was very much on the timing and length of the growing season and heat accumulation and the frequency of things like extremes like heat waves and droughts. So that's all information that's really vital to reduce the impact of climate variability and the trends in climate that we know we've started to see and we're going to see more of as we go into the future. So we focused on understanding those sorts of things at the regional scale with that hope that we could inform adaptation decision making. So the basis for making good adaptation decisions is good climate information, I think. So the main legacy of the project is this wine atlas, which Tom led the development of. And that's the aim of it is, as I said, to provide you guys with information that about the climate at the near term timescale, mid timescale, and end of century, so longer timescales. So Tom, if you could go on to the next slide, we think about what is actually in the atlas. So it's basically a summary of the changes in climate that we've already seen across the wine regions of Australia, and also the changes that we can expect going forward out to the end of the century. So it's based on the most up-to-date climate projections at the finest resolution that are currently available across Australia. And there's a separate section for every geographic indicator that describes changes to temperature, heat accumulation, extreme events, rainfall and aridity. So we've also got maps that show the variability within and across regions. And we've got many indices that were developed in consultation with people within the wine industry. So we were trying to include accepted indices that were widely used and relevant to growing grapes. So if you just click that little button, Tom, one little step further, we can see a list of all of the indices that you can find in the atlas. Obviously, we're not going to have time to talk through all of those today. Tom's going to concentrate on the most obvious ones. But it's a pretty solid list of indices that should be able to be used for many applications across the country. And so, as you can imagine, this atlas is large. It's almost 400 pages, and it's trying to cover a lot about climate projections. So it is unapologetically and unavoidably a technical document. But what we have included is a very comprehensive how to use the Atlas guide, which you'll find at the front and at the beginning of every regional section when you download it. And for those who might be slightly less interested in all the graphs, we've also included an infographic for every GI, so that summarises the changes across the region. And so if you're curious about any of the details, it's all there. It should all be entirely traceable. So if we go to the next slide, thanks, Tom. So this shows the sort of different resolutions across the country that we had from the climate models. CSIRO ran a new dynamically downscaled regional climate model, which centred over that 5 kilometre box in the middle, and then the resolution sort of spreads out as you come away from that centre. So we've got over Victoria, 5 kilometre resolution, 10 kilometres as we go out towards Tasmania and southeastern Australia. And then the Western Australian and Queensland regions, we only had 50 kilometres that gave us the full time series that we needed, and they were then statistically downscaled to 5 kilometres. So that downscaling was done for 6 different global climate models, and so the atlas presents the mean and the range between them, and that's to give us a range of possible futures. If we go ahead, so this is to show you what a climate model actually looks like. They're actually quite complicated beasts. They're amazing beasts. They have many different layers. So this is output from the regional climate model over southeastern Australia. Tom's got visualising 2 different cloud layers, a high and a low cloud layer, but actually there's about 20 or so layers, atmospheric layers there. And so as you can see, and here we've got 1 hour time steps. So as you can see, it's fully interactive between the atmosphere and the land surface. We're showing surface temperature. And the way they work is they're basically just numerical representations based on the sort of physics and chemistry of the climate system. So as you can see here, as a cold front moves across the domain, then the surface is interacting as well with that. So if we go further forward, we can see soil moisture. So here it shows really nicely that as this cloud comes across, we end up with rain, where we can see the soil moisture, which is the bottom layer. The soil moisture increases in response to rain. We can see the catchments filling up and then drying out again over time. So I think that's really important to understand, that these models really do give us valuable information, and the downscaling lets us understand the regional processes that drive climate. So they're really giving us the best available information. So if we go to the next slide, thanks, Tom. So this is just a summary again of the climate indices that we were told were the most important ones to the industry. So temperature, we're focusing very much on the growing season temperature rather than just annual means. Growing degree days is obviously really important for agriculture, and those heat and cold extremes. But Tom's going to take you through a lot of those in more detail today. So if you're interested in more general climate science, the first 1 or 2 webinars we gave, we started off right up at the top, where how do we know that climate change is happening? How do we know that it's caused by human activities? And so if you're interested in that sort of information, I'd recommend you go back to those webinars, because at the moment the science is totally unequivocal. We know that climate change is happening, and we do know that it's caused by human activity. So in the atlas, we've considered the high emission scenario, which is the RCP 8.5 that you can see up there in the red line in the top graph. And we've just got these to show that there are different trajectories that we could follow if we were to mitigate our greenhouse gases on a global scale. At the moment, we're tracking slightly above that RCP 8.5. If we were to achieve the Paris Agreement goals, we could end up at following that 4.5 trajectory, RCP 4.5. But the thing that it's worthwhile noticing is that they don't really diverge actually until about 2040 or 2050, meaning that the difference between the high emission scenario and the middle one is still very much overlapping, and this shows the range in different climate models. So that link between the carbon dioxide and temperature is solidly there and very well understood. So we have shown just the RCP 8.5, but we've also included some attempts to disassociate the emission scenario from the timescale, and Tom will show you those in the graphs as well when we get to that. Thanks, Tom. If we go on to the next slide. So I guess I've put this slide in here because it's really easy to talk about climate change as being this big global thing that might happen sometime in the future. But the fact is that we're seeing the impacts now, and we've started to see them more and more. We've seen extremes in heat, drought, bushfires, storms, hurricanes all around the world. So global mean temperatures have increased by about 1 degree Celsius since about 1910. And that doesn't sound like very much, but it has been enough to fundamentally change the Earth's climate systems. And we know that with continued climate change, that those impacts will continue to accelerate. One of the things I did mean to say is that we have a certain amount of warming that is already committed to the climate system. So even if we were to go to net zero emissions tomorrow, we know that we are going to have to adapt to changes for the next decades, because the heat has been absorbed into the ocean, the carbon dioxide and the temperature heat has been absorbed into the oceans, and they will continue to release that heat over the next decades. So it's not going to go away, and so we know we need to adapt to that to continue to maintain our businesses and into the future. Tom, if you could go forwards. So this is one of the things I really like about the Atlas, and again, it's to make that point that we have already seen climate change across the country, and that the progression into the future is just a continuation of that understood change. So here we've got 2 examples of these continents-wide maps that show the observed change in growing season temperature up on the top map and growing season rainfall down in the bottom map. So it's the changes that we've already seen and have been observed, so not from climate model output or projections, between the current period, which is 1997 to 2017, and the historical period. So whenever we talk about the historical period, we're talking about the period from 1961 to 1990. And so you can see here that we haven't had exactly the same amount of warming across the whole country. We've got some places that often because of maritime influence, for example, down the southwest of Western Australia or in Tasmania, they may have only experienced about 0.4 of a degree increase in temperature, but other regions have actually had about 0.8 degrees increase. So that's slightly lower than the global average, but it's still quite a substantial increase. Rainfall, on the other hand, is not quite so straightforward. You can see down in the bottom that we've got some regions that have experienced drying periods, drying trend since the historical period, and other regions that have experienced a slight increase in rainfall. And so that's, again, reflective or showing the changes or the differences in the regional climate systems across the country. But it's also reflecting the fact that rainfall is obviously naturally really variable across Australia. And we're not really expecting the climate change signal to really emerge for another 10 or 20 years or so. So in the short term, natural variability in rainfall is still the driving factor. So Tom, I might hand over to you, I think, at that point.
Thanks, Beck. And so let's delve into the actual layers inside the Atlas. So I'm going to go for a bit of a tour around Victoria this morning. And so we're starting off with Bendigo, and this is the infographic that starts off each individual geographical indicators section inside the atlas. There's 6 pages for each region. And here we can see, like, rainfall, for example, is going to see, quite gradual changes. They're quite small, really. And also in this particular instance, a lot of that actually happens in sort of the near term, and then it sort of stabilizes for Bendigo. For temperature, we can see there's a gradual increase in temperature of about 3 degrees into the future, following that highest scenario. And extreme cold, in the frost days during the growing season, are going to decrease, going from maybe about 2.5, 3 events a year down to only 2, less than 0, or less than 2. Sorry, just getting almost to not a risk at all. Extreme heat is measured in what's called the excess heat factor. Excess heat factor is a variable that was developed by CSIRO and the Bureau of Meteorology to kind of assess the relative severity of different types of heat waves and different heat waves that we see across time, be able to compare them to each other and be able to compare the relative influence across different regions. So if Melbourne's experiencing a heat wave at the same time as Bendigo, then what is the relative influence of that heat wave across those different spaces? And that's what EHF is for. And we can see here that there is a gradual increase in the intensity of heat waves in Bendigo. Some people might say, well, of course there is, but actually there are many regions where the intensity of heat waves as experienced by humans is not going to increase. And so this variability across the space across the nation is important to recognise and represent. Aridity, this index, a low value of aridity, this is just rainfall divided by pan evaporation. And a low value indicates a drier climate, and a higher value indicates a wetter climate. And so we can see a gradual drying out of the landscape with the combination of increasing temperature and slight decreases in rainfall. That results in increasing aridity, which is fairly straightforward. Again, it's not always the same story across all regions, but for Bendigo, this is a nice intuitive one. If we then go forward and we start delving into the detail of the atlas. And so here we can see there's some quite technical figures, and I'll talk through each one of these. So figure 1, which is observed mean growing season temperature here, we're talking about the Yarra Valley now. We can see that across the Yarra Valley there's quite a strong east-west trend, with the west being warmer and the east being cooler. And we can see that sort of variability of where you're positioned across that zone will have a big difference. And these, again, remember, this is the observed data from the Bureau of Meteorology, not any future model data at this point. We can see there's been quite a, when it comes to the actual increase in temperature, as is kind of experienced across the globe, it's been relatively uniform across this small region of close to about 0.8 degrees. No regions in Australia have been cooling over this sort of previous sort of 30, 40 years. Everything's been warming slightly. And when we go and then look at, in figure 3, at the future projections, these capture this regional variability and then also show how that's going to change into the future. And again, it's a relatively uniform increase in temperature, maintaining those same spatial heterogeneity that you might see today is maintained into the future. Just all of the temperatures are shifted upwards into the future. So looking at growing season temperature like this, there's obviously lots of grid cells here, and for each individual time step in a time series, we've put every single one of those grid cells onto this figure 4 plot. And so we can see there's the colder regions are down here. They are more similar to maybe Tasmania's east coast, and the warmer regions of the Yarra Valley, which are maybe more similar to Coonawarra. We've got these locations yeah, so that's all of the locations represented across that Yarra Valley region. If we follow one of these locations, following it as a single time series, we've got a warm location here that's presenting off into the future, and we see that it's not experiencing those really extreme conditions there. But they're quite extreme conditions for it by the end of century. And similarly, you've got a cooler location that can be represented here, and that is going to be much sort of as warm as the warmest areas by the end of century, is really where what that is saying. So across this region, you've actually got quite a lot of heterogeneity, and there's actually capacity to move within the region to different locations. If you look at this at a very kind of broad scale and don't take into account land use management in this particular region. So I mentioned that we've got these bars here that are there to try and represent, you know, what the distribution of growing season temperature might look like across the country if you take averages. And as you can see here, Yarra Valley has an average of about 16.5 degrees, but across the Yarra Valley there's an enormous amount of variability, and this is true of all the regions. So it's important to keep these bars in kind of mind, that in each individual one of these regions there is that variability. Smaller, more focused regions that much flatter, like Coonawarra, they have tighter zones and less variability, but Yarra Valley, as you can see, is actually one of the more variable of the regions across the country. This time series also represents that we do have these hot years and cold years, and they, you know, here for example, this warm year that, you know, was all the way back in 1970s is actually a little bit of a flag of, you know, the kinds of conditions that we should have been experiencing on sort of far more regularly, or even on average by say 2040, 2050. So these warm years that pop up, and that, such as 2016, such as those in the past, can be seen as at the time they were extremely hot, difficult years to manage, but they've got to be seen as flags of what the future is going to look like and what kind of conditions we might need to start adapting to manage as they become more and more frequent, which is what's projected to happen from 2020 onwards. And these projections, even projections of the front that were done originally in the 1990s, they have all identified that about 2020 is the year when the future climate emerges from the historical climate and becomes different. And that's what we're observing at the moment, is as these changes occur. You'll also notice I've got this panel in the background, these orange panels, and what these represent is global climate change. So global climate change of greater than 1 degree occurs over this time period here. Global climate change of greater than 2 degrees occurs over this time period here, and 3 and 4 degrees. Now, the reason we've done this is so that you can actually look at this in terms of temperature change, not in terms of time. So if, for example, we manage to meet our Paris agreements, we keep global climate change to below 2 degrees, then we're going to probably end up with conditions that are mostly like this all the way out to the end of century. And that means that this document remains useful for making long-term decisions and framing long-term decisions by using this data and the data from the other regions. It remains useful into the future because we're looking at it from a temperature change point of view rather than just a time point of view. Similarly, if we don't meet any of our agreements and we don't make any dramatic changes, and climate change, it actually accelerates because we release more carbon dioxide into the atmosphere, then we might end up having a greater than 4 degree warmer world much earlier. And again, this is where that data is still useful as in say 20 years time, when these particular events start to become clear and can inform what those decisions, like what the climate is that can inform those decisions. And so separating out the temperature change from the time series was an important thing to be able to present, and we've managed to capture that in all of the time series figures that we've got there. Now, if we take these all of these points across the entire Yarra Valley region, all these locations, and when we look at them inside a particular time period, so let's look at the one we've got here of 2000 to 2020. All of those those variables there can be looked at as a probability distribution function, which just says how often does each individual value occur. And so in this case, in the 2000 to 2020 time period, the most common value is something around sort of 17 degrees. But there are also locations in each one within the Yarra Valley, which had a growing season temperature that was down around sort of 12, 13 degrees, and others that were having values up at sort of around 18, 19 degrees. But they were small. There was only a small number of locations, and that only happened a small number of years. And so it kind of counts up that whole frequency. Now, what this allows us to do is to see how is this particular expected climate, how is it expected to change? And if it's expected to change, who are you going to become more similar to into the future under those conditions? And here we've got, again, the probability distribution functions for some example regions in shaded grey in the background here. And following the high emissions scenario, the Yarra Valley is going to become a little bit more similar to Geograph in Western Australia than it is to the Yarra Valley today. Even now, as we move from 2020 to 2040, Yarra Valley is going to have a lot more conditions that are more similar to Coonawarra in terms of temperature than it is into itself. And so it's kind of edging warmer. And you can see it's just this gradual progression in temperature into the future. In a similar way, we've calculated growing degree days, and to sort of represent what the maximum growing degree days values are achieved over the entire year. Now, these values obviously are sort of showing that total amount of heat that comes through the whole season, and a lot of that heat comes through after the harvest has happened. But this gives a good indication of which regions you're currently similar to, and which regions you're going to become more similar to into the future. And here we can see that in terms of growing degree days, and similar to growing season temperature, Yarra Valley has a lot of areas similar to Tasmania's east coast, and another sort of zone more similar to Coonawarra, and they would be captured in this sort of east versus west divide that we've got across this region. Now, growing degree days is typically calculated from October to April, and is only adds up values greater than 10 degrees C. Now, when we're doing climate projections, one of the key things stakeholders wanted to say, what is the date when growing degree days is going to reach key thresholds into the future? So here we've got 1,000, 1,500, 2,000, and 2,500. Now, this because for different varieties, you have different thresholds that matter, you have different points that matter. So for some varieties, it might be that flowering happens when you reach a value of 1,000, and for other varieties, they're already being harvested when you reach that kind of number. Now, in a climate change scenario, we can see that there's actually quite a lot of heat that's getting accumulated prior to October. And if we don't capture that increase in heat over that part of the season, we're not going to capture the influence that it might have on these phenological stages. So we had to change the index, and the index had to be from July to June. It had to be also for many regions across the country, a base value of 10 didn't actually produce very meaningful results, and so we had to change the way that those thresholds of incorporating values were there, and this is all described in the methods and background material of the atlas. So from July onwards, all values greater than 0 were counted, and those until you reached a threshold of 1,000. Then after that, we included values that were greater than 4 degrees only, and then once that reached a value of 1,500, and then of that values that were greater than 10 degrees were only included. And that helped to capture that change in phenological requirements. So as a grapevine is growing in spring, it doesn't need as much heat in order for it to really progress its growth. But then as it sort of has bigger leaves and it has more demands, it actually needs more energy in order to really make those changes. And this is all based on some literature by Moncur. And so we've applied this particular growing degree days method. And we've compared it to all the other growing degree days method that we found people were using across the country. It was not as standard as everyone likes to think. Now, when we look at this, let's have a look at accumulating this heat. From July to October at the moment, you're ending up in Yarra Valley getting a value following this one of about sort of 500. Now, by the end of century, that's going to move forward by 4 weeks, achieving that value. So that 4 weeks that is of moving forward, if we didn't include July to October, we would have missed that increase, that moving forward of the entire season by 4 weeks, which all happened early in the season. And if we then go out to say hitting the first threshold of 1500, that's currently happening, around the middle of February. And by the end of century, we're looking at it happening sort of, by, the middle of December, maybe late, the start of January. That's a kind of rate that's a little bit more similar to what they're currently seeing in the Hunter Valley. Harvesting times being around sort of Christmas, New Year's. That's a moving forward of about 6 weeks. So of that 6 weeks that it's moved forward, 4 weeks of it happened prior to October. And that was the big reason for us needing to move that. Now, once we have this climate-ready growing degree days index, we can then start assessing those dates. And that's what these probability distribution functions here are doing, is they're saying, here is how often we reached a threshold of 1,000 at a particular date. And it's mostly been happening in the middle of December here, but that's going to shift forward to being sort of at the start of November by the end of century. These figures at the back here, which are really quite messy, they're messy because there aren't that many occurrences of 2,500 in the data set. It doesn't actually reach that value every year. And we can see that here in our, over here, that 2,500 is a threshold that is only sometimes reached. And that's why these look so crazy. So moving on to rainfall and focusing on now the Alpine valleys. The Alpine valleys, we can see that across the observed record, there's quite a strong difference across this space, with a much drier region out sort of, northwest of Myrtleford, and the wet region really up in those high elevations. What's been happening over the past 30, 40 years is that there's been a general kind of almost very slight drying, if anything, in that kind of valley floor. And then up on the mountains, there's actually been a slight increase in the rainfall over this particular small sub-region of the Alpine valleys. If we look at how this is projected to change into the future, however, there's very, very minor changes. We're not seeing significant changes here. This is quite positive. It means the rainfall is going to be, relatively similar. It might be slightly decreased, but it's not a significant change. And this is projected. This is reflected in the variability and trends that we see in the time series. There is a lot of rainfall that can happen in any 1 year in this region. Very, very wet years compared to very dry years, and very wet locations compared to very dry locations across this space. The growing season rainfall presented here in figure 4 is not projected to change very much at all into the future. There's almost no trend there. However, the non-growing season rainfall, May to September, has already been observing a slight drying trend, and that drying trend is set to continue into the future, although it is quite gradual, and it's mostly a decrease in the number of really high intensity, very wet years is decreasing, and sort of having more average years. And this is an important thing to think of about in terms of your storages and how much water is going to be available for use across those entire regions for agriculture and the like. Now we can also break this down and look at it in terms of monthly rainfall. Now these, in figure 6 here, we've got what's called violin plots. Now these are probability distribution functions that have been put on their side and mirrored each other. And what these do is they highlight the most likely rainfall you're expected to see in any one month. So in this particular instance, it's saying July is most likely to have about 150 mils. And then as you move over into sort of the drier months, you're looking at December where you're kind of expecting to have, it's hard to see there, but maybe 10, 20 mils through that dry period and then it increases again into the as you enter back into winter. Then we've shadowed these sort of historical conditions underneath each one of these future projections to see how it's changing. And what we can see across here is that there's actually quite a strong drying trend in July, August, September. But there's actually an increasing rainfall that is expected in December and January particularly, with some quite high rainfall events expected to happen into the future in those months. So there's a real change in the seasonality that is expected to occur, although most of that it's going to happen quite gradually, but most significantly after 2060. If we then have a look at these sort of like seasonal summaries and how things are changing, there is a gradual shift of winter rainfall towards a drying trend here. And there's sort of two kind of step changes that happen. One that's happening almost now, that's minor, and then another that really starts after 2060 that dries a little bit more intently. And that's one of those changes that we're hoping to avoid. Whereas this first initial shift, which is happening from about now onwards, we're definitely going to have to deal with that change. Now these changes are relatively minor, as you can see. These curves are not moving very much, and that's also represented by the distribution of rainy days during harvest in figure 8, which is showing that there isn't really that much of a difference, except for this sort of very high value of 2,500, and that most of that change is actually expected to occur right now as the drying, as that value shifts more and more into the sort of the summer period and away from that autumn period. So I'm sticking with the Alpine Valleys here to talk about aridity and say, well, we've got this drying trend, and the drying trend has been, very minor really, but it's resulted in quite significant increases in aridity, so a drier landscape. So although we've only seen, changes that are probably not even statistically significant in rainfall over the historical period, they've resulted in an 8% decrease in some zones, an 8% intensification of dry conditions. So it's much drier here than it used to be. And this trend is far more obvious into the future than any changes in rainfall were. So as we see sort of in here, the Alpine Valleys, it's a very wet place. There's a lot of water, and so there's a lot of locations that max out this index and exceed this sort of value of 2, which anything greater than 1 is just basically saying you're very wet. But as we can see from about 2020 onwards, we're starting to get a bit of a thinning of this, and more and more locations are actually moving away from that very wet conditions and are drying out. And that's also true at this sort of drier end of the spectrum as well, across this zone. We can see kind of two kind of big step changes. One is sort of at about that 2020 mark, and the other is at about sort of this 2070 mark, right down into the far future. This is reflected again in these violin plots, where we can see how these are all changing, and this particular shadow here is starting to become, more visible underneath this, as there's a bit of a extension down into very, very dry years across the entire zone, and that's true of all of these particular violins in this presentation. The step change that we can see is, we can see it here in spring kind of quite clearly, that there's a big shift that's going to happen from about 2020 onwards, but that's going to be kind of solid expected conditions until about 2060. And then there's another big shift that starts to occur sort of about 2060, 2070. So in terms of time horizons, one of them is imminent, but then we've got quite a long time to adapt and see where the climate goes over the next 50 years. In terms of how dry a particular season is going to be, we've got early in the season is drying quite significantly, particularly in the immediate term. And then as we go across the whole season, it starts to sort of become less of a change than what we see at this early stages, where a GDD threshold of 1,000 is reached. And until we get to the far future, and then the far future, there's a very, very large significant drying trend that happens, which is really quite obvious in the time series here. Getting on the bus and moving around Victoria now, we're heading over to the Grampians. Here in this particular, these extreme plots, extreme heat pages, we're presenting the excess heat factor, the actual number of days that extreme thresholds have been reached. For looking at those extremes in percentiles, for those of you that really love statistics, looking at severe risk to humans, and then looking at the actual temperatures that we should expect to experience from heat waves into the future, and when they are likely to occur. So going back to figure 1, we've got the observed mean excess heat factor across the Grampians region. And we can see here that it's quite homogeneous across this zone, which is not unexpected. Heat waves occur over large spatial areas. They're synoptic in scale, and that's kind of reflected across this zone here. However, the changes that we're expected to experience, the southern region is not going to experience as much of an intensification as the inland, the further inland or the northern region of Halls Gap, with particular intensity here, sort of, east and northeast of Ararat. These extreme heat factors, particularly when we start getting up sort of greater than 2025, are starting to get quite high, some of the highest ones in the country. So the heat wave intensity by the end of century, but even if you look at what's happened in 2040 to 2060, they're quite high there, and that's something that this particular region will need to watch. And there are many regions where heat waves are not an issue, but in this particular region it is. When we look at these, so excess heat factor is explicitly focused on how heat will impact on humans, and how the multi-day impact and the overnight temperatures will impact on humans' capacity to recover and adjust to heat into the future. And so what I'll do first is I'll skip from figure 3 to figure 7 and talk about that, because it's all related to that heat wave discussion. Overnight minimum temperatures are an important part of this excess heat factor calculation. And we can see that the historical period, overnight temperatures were about 20, but moving forward from basically today, we should expect to see a quite dramatic increase in overnight temperatures during heat waves by 2 or 3 degrees for this particular region. This is quite dramatic. It's some of the biggest changes that we see in the country in this particular time period. And obviously this is similar for many of the southeast and South Australian regions. So this 2-degree increase in overnight temperatures is happening in this kind of step change again, where it's going to stabilise there. It's projected to stabilise there for about 40 years, And then there's another big step change that will occur as we enter into that 2060 and onwards. The maximum daily temperatures, on the other hand, are going to stay basically about, you know, more or less the same, not a big shift in the next 20 years, but from 2040 to 2060, that's when those daily temperatures are having a big shift, with some quite dramatic temperatures being projected to be possible into the future. Those high 40s, even pushing 50. And remember, these are averages across kind of 5-kilometre grid cells. So there'll be particular locations which are much hotter than that. And then once again, there's another big shift, but after 2080, which is probably accompanied with that particular intensification of aridity in this zone moving forward. Now, if we look at the frequency of how often days greater than 30, for example, are going to occur, historically we've kind of seen, you know, maybe a whole month, 30 days a year or thereabouts of days greater than 30. But from 2020 onwards, we're really kind of expecting that to edge up towards sort of a month and a half to 2 months of the year being greater than 30. And then it's moving up to sort of more like 3 months of the year by the end of century. This obviously brings with it some intensification of those other thresholds of greater than 35, greater than 40, and greater than 45, with temperatures, you know, greater than 45 really emerging as something that's a big and kind of a typical new risk that is across the entire region by sort of, you know, 2060, and that's kind of reflected in these heat wave values that we're seeing. The distribution of heat waves is not really expected to change too much, but this is largely due to the fact that heat waves is always considered based on the previous 30 years, and therefore the heat waves will always occur in the middle of summer following that particular assessment. However, there are another way of assessing, say, a warm spell or a heat wave that is much more that cares about these thresholds, and that isn't being captured in this particular assessment. Now, in other regions around Australia, particularly, say, very humid regions, the severe risk to humans where humidity is greater than 60 degrees C and it's also greater than 30 degrees at the same time, it's an increasing risk. Now, we can see over the past sort of historical period, there's been 1 or 2 days a year where you might feel really, really uncomfortable outside working in the Grampians region, but typically it's so dry that it's not really a really heavy, hard heat. However, the frequency of this is dramatically increasing into the future, particularly after 2060, where it's going to become an emerging risk under a high emissions scenario. In terms of looking at this from a national perspective, these are very low numbers. In the Hunter Valley, for example, and some areas in Tasmania, they're actually expecting to see sort of the whole of summer becoming something where you need to have special equipment to work outside because of the high humidity and high temperatures. So although this is an increasing risk and is something that I think managers of people really need to start thinking about how safe it is to be working on particular days, it's something that is sort of, you've got plenty of time to adapt to that particular coming risk if you keep your eye on the horizon for that one in the Grampians. There'll be other regions across Victoria where that's something that's really worth looking into. Okay, back on the bus and moving over to Goulburn Valley. Goulburn Valley here, this is a representation of how extreme cold is going to change. And as you might expect, given the warming climate, extreme cold conditions are typically expected to decrease into the future. However, if we look at what's happened over the past 40 years, there's actually been some increases in frost over this region. And this is to do with having more clear sky nights. This is a well understood phenomena. More clear sky nights results in a few and potentially unexpected frost events. And it has slightly increased, but look, the numbers we're looking at here are relatively small for this region, looking at maximums of 4 per year, and it's gone up by 1. So seems like a dramatic increase, but frost isn't a really big risk for this particular region compared to many others. But into the future, these particular, like these clear sky nights, even when they happen, we're going to have so much heat in the system that we're not going to end up having these frost events, and they pretty much drop off to being completely inconsequential, even sort of from 2020 to 2040, or even, or maybe from 2040 onwards. When you look at sort of the important part of the growing season into the future. Overnight temperatures are going to dramatically increase. This can have particular impacts on harvesting times and harvesting methods, depending on how hot your location is and what you're expecting what your expectations are. And then it doesn't matter which way you plot the frost risk days, whether it's the intensity, the frost risk accumulation, which might be good for, say, apples. You might need to have a lot of cold, and that particular to really trigger some phenological responses. The cold that you might have expected in the historical conditions is going to dramatically decrease over the next 20 to 60 years. Oops. Thought it took a bit of time to catch up to me. So we've got all of this information for each individual region, but we've also presented this information so that you can compare yourself to other regions around Australia and potentially build alliances with those that have similar problems, or maybe they have problems of your future. And so you can start building those alliances with them and understand, how do they manage those particular risks? How do they manage those challenges, and what do they grow well given where their climate is, and that your climate might become similar to theirs. And we've got that for all of the variables that we've presented throughout the atlas, presented there in the kind of national overview. We can also present this in a different way and put everybody on a similar plane. Here we've got mean growing season temperature on the y-axis, and growing year aridity index on the x-axis. And so we've got very wet conditions here. So we've got the alpine valleys, for example. It hasn't really dried out very much recently. That's really projected to happen over the next 20 years, a quite significant drying trend. But it has warmed quite a bit recently, and then that warming is going to continue into the future as it dries. And as you can see, it has one of the most dramatic traverses across this particular conceptual space of warming and drying of pretty much all the regions in Australia, matched pretty much only by Pemberton, which is absolutely astonishing where that's going. Now, what this means is that alpine valleys might become a little bit more like Shoalhaven Coast into the future, and therefore that's one of those locations that they could start looking to and saying, oh, well, what do they do well? What are the challenges they manage? How can we adapt our practices over the long term to maybe take on board some of those, the positives, and avoid some of the negatives of, say, Shoalhaven Coast or Pemberton. Similarly, we've got the Grampians and Geelong and Sunbury sort of hovering over here, and they're going to move to become a little bit more like the Goulburn Valley into the future, and the Goulburn Valley itself is going to be moving up and become a little bit more like the Riverina. So this plot allows users and managers of small and large enterprise to have a bit more of an understanding of the diversity of locations across the country, and where you might be moving to into the future, and what does that mean for your strategies? What does it mean for when you're engaging with the marketing department about how your wine label is going to be expressed into the future? What does it mean for what you might be planting if you're putting in new plantings? What are the strategies you might be putting into place to really optimize the investments that you're making today, so that they're, I guess, future-proof? They're in alignment with what the future climate is into the future. So I'll hand back now to Beck, and we're almost done.
Thanks, Tom. That's a really nice overview. You've been lots of talking for you. So I will just really be quick because we are sort of getting towards the end of our time. But so just to summarise that we know that change is already occurring, and the observations show that, and that those trends are projected to continue. There is a lot of variability across the country, but there are consistent trends across all regions. The first and most obvious one of that is that strong warming trend, which is set to accelerate actually as climate change continues. All of the regions show increases in annual temperature and growing season temperature, and increased aridity as we have that effect of evaporation regardless of what rainfall projections say. They generally have fewer frost risk days and many more intense heat waves, regardless of which way they are measured. And then in many regions, we do have that substantial increase in the excess heat factor. So we know that adaptation is going to be required, but we also know that with good climate information, and particularly I think with the concept of the climate analogues, then we have got tools at our disposal that we can learn from and transfer across regions to help us plan for the future at those different time horizons. So what do we need? What can we do for the next 20 years, the next 40 years, and the next 100 years? So I'll just quickly go to the next slide and say thank you to the research partners, who included Peter Heyman, Paul Petrie and Dane Thomas from SARDI, Fiona Kerslake from TR, the Tasmanian Institute of Agriculture. The modelling was done by CSIRO, led by Marcus Thatcher. And as we said, we were funded by Wine Australia for 3 years. But particularly, I wanted to thank the wine growers that helped us decide what was useful information and helped us iterate to try and make sure that that climate information was useful to you. So I will leave it there. Tom and I are happy to stay for some questions, even though we're over time, if you have any. Back to you, Sharon.
Thanks, Tom and Beck, for that fantastic presentation and a bit of a deep dive into what the Atlas is telling us about some of the regions in Victoria. You've been pretty quiet over there in Vic. If you can think of any questions as we go along, we've got a few minutes for discussion. Please type them into the chat page and we'll get to them. Alternatively, if you think of something down the track and you'd like us to address it, please email us. Belinda will post the link through to our email address. And if you're leaving us now, it'd be great if you could complete a survey on the webinar today so that we can improve our offering down the track. So I'll ask a couple of questions. How confident do you think we can be about the projections that you've talked about today?
Do you want to take that, Beck?
Yes, I can answer that. So the projections that we've presented in the Atlas are from an archive of climate models that have been accepted by the international climate modelling and climate science community. It's very hard to say which model is correct because obviously we're talking about the future. In fact, the biggest uncertainty is really about what humans will do and whether or not we will change that trajectory of our emissions. But what we've also done in the Atlas is give a range of those climate models so that we are capturing a range of what is considered plausible. So we do include a particularly hot, dry model and a slightly wetter model, for example. That is all quite relative, though. All of the models that are in the archive project substantial warming by the end of the century, and so we've represented that range in the Atlas. So I feel pretty, we can be fairly certain in our projections. Certainly temperature. Temperature is well modelled and well understood. Rainfall has a bit more uncertainty around it. And I think that's why also it's really useful to think about the aridity index. So that drying and warming trend is solidly there, and I think something that we can take quite a lot of
excellent,
confidence
thank you.
in.
And along similar lines, we've had a question come through. Is there a plan for, say, 5-yearly updates to the Atlas as things change? I guess as we know what how our emissions are projecting.
I think that's a question for you, Sharon.
Oh.
I can answer that quickly though. So So every 5 or 6 years, there's a new archive of climate models that comes out. So at the moment, we're waiting. This is based on CMIP 5, and this links into the IPCC assessment reports, the Intergovernmental Panel on Climate Change. So the new archive, CMIP 6, is just now emerging, but there's always a bit of a lag. So the new models come out, and then they have to be analysed and validated, and everyone argues over them for quite a bit. And then you would have to downscale it. So even the downscaling that this project funded took 18 months, or actually 2 years. So there's that lag as well. So there comes a time when we know that we have really good information, and we have enough information to know that we can start planning for our adaptation and for futures. I don't think that continually updating the models will actually really substantially change the projections that we have to plan for. So since over the last 20 years, the message from the climate projections hasn't changed. There's a little bit of change around the edges, but generally those messages have stayed the same, and they're expected to largely stay the same with the new archive. So at some point there would be a need to update, but I think personally that every 5 years would be a bit of overkill, because it's really expensive. These models produce huge amounts of data that have to be stored. They take a lot of people's time to understand what they're doing and to make sure that to validate them, to bias adjust them, and so forth. So I think that we will need to update them, but we also just need to get cracking and planning in our adaptation responses.
Sure. So keeping an eye on it as we go forward, and we've just entered a new strategic plan at Wine Australia. In 5 years, we'll be starting a new one, and we'll be starting to think about what comes next. And along similar lines, we've had another question. What's the level of confidence for the 2020 step change?
Level of confidence is actually quite good. It's quite robust across most of the models, strongly related to the increasing temperature over the entire Australian continent, and that's having an influence on the subtropical ridge, which is a big atmospheric feature that it kind of separates the warmer conditions over mainland Australia and the cooler conditions south in the ocean. And so as that particular feature sort of shifts further south, then there's a decrease of rainfall across the whole of southern Australia. Those trends have been seen since about the 1970s in both Western Australia, southwestern Australia, and Tasmania particularly, but you can also see some of those over in the sort of southeast, South Australia and Western Victoria as well. So we've got quite a lot of confidence that those types of step changes are coming. What we don't know is what year is it going to happen, because that isn't how projections work. We're looking at big kind of multi-year summaries from multiple models, but it's more about looking at those trends and knowing that, okay, that's the direction of change, that's where we're going, and here's the magnitude of that change that you should be able to expect. And that's where this information will be quite useful for guiding those kind of decisions on which way you lean in your operations.
Sure. We've got a question here on Murray Valley, which I'll address. So Murray Valley will have its very own webinar coming up. So if you're interested in Murray Valley, Swan Hill, Mildura, that kind of area, please visit the Wine Australia website and sign up for the webinar on Murray Valley that's coming up in the next tranche. I think we should probably finish there. We've gone a few minutes over time. So please link through to the survey that's in the chat page and let us know what you thought. Next steps are that you'll receive a follow-up email with a link through to the recording and the survey if you missed it today. The recording will also be available on the Wine Australia website in the same place where you registered. And you can also find links through to the Climate Atlas itself, which you can download in its entirety, or in the particular region that you're interested in, and the ABC landline story on the Climate Atlas, and the final report for the Climate Futures project that delivered the Atlas. And we've posted links to most of those on the chat page also. So don't be a stranger, reach out. This is just the start of the conversation. No one needs to do anything today or tomorrow or next week. It's a long-term planning tool. So start talking about it in your regions and between each other and individually, and think about how it might help you with your adaptation going forward. So I'd like to say thanks very much to Tom and Beck for their fantastic presentation and their time, and thank you very much all those who dialed in. I hope you got a lot out of it, and take care and bye for now.
Thanks. Bye.